Hello, and in this video we're going to look at how to conduct the paired sample t-test by hand. This is a test to compare the means between two groups on one continuous dependent variable when the entities creating the two groups are the same people tested at different times. So this is a very simple test to show how to conduct on SPSS, but it's also a very simple test to calculate by hand, so I'm going to show you how to do that. So if we dive in, here's the data we're going to be using, and it's just two groups of five people that have been measured on a score for depression. They've been measured pre-treatment and post some treatment, and obviously we're hoping that the post-treatment they're less depressed than they were pre-treatment. So as we've shown in previous videos, the first thing we need to do is calculate the means of these two groups, and that's just the number of scores, the total of the scores divided by the number of scores contributing to the group. And we also need to calculate the standard deviations, which I showed how to calculate in a previous video. So to conduct the test to see the difference between these two means, 11.8 and 8.4, is statistically significant, the first thing you need to do is calculate the difference of the individual scores. So the first person pre-treatment, they had a score of 13.7, and the second score, they had a score of 7. So we're gonna calculate that. Doesn't matter which way when we do this, but conceptually I chose to do post-treatment minus pre-treatment because it stands to reason that we'd want to be dealing with minus scores when we're talking about a treatment or reduced depression. So we've calculated the difference, and we do that for all the scores. So pre-treatment minus post-treatment. Here are all the scores. What we need to do is follow the standard procedure for calculating a mean that I talked about before, and if we do that, the mean of those different scores is minus 3.4. We also need to calculate the standard deviation, again using the exact same procedure that I discussed in a previous video, and if we look at that, that's 3.21. If we can then take those scores and calculate our T-statistic to work out the significance of this difference. The first thing we need to do though is, a part of the T-statistic is the standard error. All test statistics are basically a ratio of the amount of variance we can explain by in our data. So the amount of variance created by the treatment versus the error or uncertainty in the estimate. And to calculate the uncertainty in the estimate, we just need to take that standard deviation that we calculated for the difference and divide it by the square root of the sample size. So we had 5 people, so if we substitute in those values, the standard error of the difference in this case is minus 1.43, and we've calculated the bottom part of the equation. The top part of the equation is the difference that's created by our experimental effect is basically the mean of those differences that we've previously calculated. So if we substitute in those values, we get a T-statistic of minus 3.4, which was the mean of those differences we calculated, divided by minus 1.43, and we get a T-statistic of 2.38. Now, the next thing we need to do is calculate the degrees of freedom. If you remember from previous videos, all test statistics have degrees of freedom. Basically, the idea that if less people or less entities contribute to the score, then it should be harder for it to be significant because there's more uncertainty in the estimate because you tested less people. So to calculate the degrees of freedom in this case, the degrees of freedom for a paired sample t-test are the number of people you tested minus 1, because if we think back to the ANOVA video, the degrees of freedom represents the number of entities you have, or the number of entities that are free to vary, and because this is based on the mean of the differences, we calculated one mean, so that mean isn't free to vary, so we want our sample size -1. So with those two statistics we get a p-value of 0.0077, which is just above 0.05, so it's a non-significant difference. So that's saying that these, if we go back to that's saying that 11.8 and 8.4 don't differ significantly in this data, or alternatively that participants did not get significantly less depressed from pre-treatment to post-treatment. So thank you for watching this video, and I hope you enjoyed it. Bye bye.